Right. Good morning to all. Now this is a continuation of the previous concept. Just we concluded the concept of time scaling. Time scaling has two conditions. One condition we discussed. Now just we are discussing the second condition. Second condition. Now just look at, as discussed in the previous one, just we are considering a signal. That signal is t, x of t. Amplitude 2. In the previous case, just we discussed this is the signal. This is the actual signal given. From this signal, just they will ask us find or sketch the graph of x of, for example, t by 2. Sketch the graph of x of t by 2 graph. Just what we discussed, two conditions arise in time scaling. Now we are discussing the second concept. In x of t by 2, this is t by 2. T by 2 means what? Half, that is multiplied by t. Here half means what? Half is always less than 1 but greater than 0. Therefore this is 0, 1 by 2 greater than 1. So this is the condition we have to apply here. In this case, wherever and whenever the given multiplier is greater than 0 but less than 1, then the signal will be expanded. Now just look at, first we have to, what to be done first in the first case, what is the amplitude? Here amplitude is what? Amplitude is equal to 2. Next, what is the period or width? What is the width of this one? Width of this one equal to x of t, that belongs to which one? 2, 6. 2, 6. Now this is width, period or width. So use the word width. Width of this one. Now width of x of t by 2 signal. Width of x by 2 t by 2 signal. This will be belongs to, just look at, in the previous case what? 2, this is 6. Now this is divided by 1 by 2 divided by 1 by 2. Therefore the width will be 4, 12. Now the width of the new signal will be 4, 12. Now this, from this, the graph of x of 2t, that will become like this. This is t, this is the graph x of, this is not t, this is 1 by 2t, t by 2t, that is x of t by 2. X of t by 2. That is equal to, now just look at the width 0, 1, 12. What is amplitude? 1. This is amplitude 2. In this one, in this time scaling operation, amplitude always remains constant. There will be no change. So this amplitude height is same. Now what is the new width of this one? From 4th to 12. From 4th to 12. Therefore from 4 draw a signal up to the amplitude 2. Up to 12. Draw a signal up to the amplitude 2. Now just look at, this is the new signal of x of t by 2. Now just look at, this is the base signal x of t. That is the new signal x of t by 2. X of t by 2. Now what happens? Here the signal is this much, 2 to 6. Now the new signal width expanded from 4 to 12. 4 to 12. So either the signal can be expanded or the signal can be reduced. In these two cases, we discussed the examples of time scaling. Time scaling. Now just here again we are making this one time scaling. Time scaling. This concept always based upon where the multiplier is less than 1, the signal will be expanded. If the value is greater than 1, the signal will be reduced. These two concepts students should understand and remember. Again, I am telling that time scaling always takes place on vertical axis only, but time shifting takes place only on horizontal. Horizontal means parallel axis, horizontal axis, time axis only. These two are very important things. Now, the next concept is time reversal. Time reversal. Now, the third concept, that is called time reversal. Time reversal. This is the third concept, time reversal. Now, some more examples we have to perform. On these two examples, this will be after completion of unit step function and unit impulse function. Up to that, just we have given the basic properties of time scaling only. Now, applications we will be discussing the next after completion of two topics, we will make continuation of these applications. Now, this one, time reversal. What is time reversal? For example, look at x of t is a signal. Now, its time reversal. Its time reversal will be x of minus t. If x of t is a signal, then x of minus t is time reversal, just reversing. For example, look at, take this signal or take any other signal. For example, just look at x of t. This is t. This is x of t. A 0, 1, 4. Amplitude 1, amplitude 2. Now, there is a signal. What is this signal? This is the signal. Now, for this signal, what is its amplitude? Its amplitude is what? How much? That is equal to 2. But what is the width of this signal? The width of the signal is x of t, that belongs to 1, 3. 1, 3. That is the width of this signal. Now, from this, what we need? They ask you, sketch the graph of the signal x of minus t. Now look at, this is x of t signal. It will be given by them only. They will ask us. Now what they ask, based upon this signal, draw the signal of x of minus t. For that purpose, students have to make it for, just look at, what is the amplitude? This is the amplitude. What is its width? 1, 3. In time scaling and reversions, amplitude never changes, always remain same. Amplitude never changes. Now just look at, for this purpose, what graph we need? We need the graph of x of minus t. X of minus t. X of minus t, just look at 1, 3. So now x of minus t, this belongs to, just look at 1, 3. Reverse the width, 1, 3, it will become what? 3, 1. So this will become 3, 1. Keep or put minus signatures between these two. That is the time reversal. Time reversal. Then the same signal, in which way just we can sketch it? Just look at. Here, this is the graph. This is t. Now we are making sketch of x of minus t. Now minus 1, minus 2, minus 3, minus 4. The amplitude 1, 2. Amplitude never changes, always constant. Now the period is from what? minus 3 to minus 1. So here, this is the middle point, minus 3 to minus 1. Now just look at, this is the sketch of the new signal x of minus t. Now just look at, in the given signal, this is on the right hand side on the positive axis. By using the time reversal concept, the same signal is appearing on the negative axis. The positive axis, now it is appearing on negative axis. If it were given a negative, it will be appearing on positive axis, this one. For example, just look at, there is a signal. The signal is like this. This is t and this is x of t. For example, 0, 1, 2, 3, 4. Amplitude, for example, height is 2. This is the signal. This is the signal. This is x of t. For this signal, in the previous case, just we use a triangular signal. Here we are using a rectangular signal. For understanding purpose, we are using different signals. Now for this purpose, what they ask, find x of minus t. What is x of minus t? That means sketch the graph of x of minus t. So for this one, students have to make what? Here the width of the given signal, that is belongs to which one? The width belongs to which one? Minus 4 to minus 1, because it is on negative axis, minus 1, minus 2, minus 3, minus 4, negative axis. Now what we have to find? X of minus t. Now x of minus t means what? X of minus t, that belongs to reverse. Reverse means what? This is minus 1, this is minus 4. Reverse. After that, multiplying with the minus becomes plus. So the width of the new signal will be from 1, 4. Therefore, the new signal will be like this. This is t. This is x of minus t. Amplitude 1, amplitude 2. Time intervals 1, 2, 3, 4, 5. Now the new signal will be like this. Now just look at, in the previous case, the signal was on the negative axis. Because of the time reversal, the signal is now on the right side, that means positive axis. This is the concept of time reversal. So one important point, students have to remember that time reversal means what? If any signal x of t is given to us, just multiplying with minus with a time variable t, that is called time reversal. These two examples are very much important. In the first case, we use a triangular. In the second case, we used a rectangular. These two different cases are for the understanding of students' understanding purpose. These two are important. So now 3 important cases we concluded. The first one is called time shifting. The second concept, time scaling. The third one is called time reversal. In all these cases, what are changing? Only width of the signals are changing. Amplitude never changes. This point students have to remember again and again, very important point. For these operations, we are making operations on width of the signal only, not on amplitude. So these 3 are important concepts with respect to time domain signal operations. Thank you.